Hey guys, this one is absolutely amazing. We're going to look at this infinite nested radical product. And along the way, there are actually 3 surprises waiting for us. So stick around. It gets very beautiful. Here's the expression. P equals square root of 2 over 2 times square root of 2 plus square root of 2 over 2 times square root of 2 plus square root of 2 plus square root of 2 over 2. And this just keeps going. If you want to give your brain a little workout, pause the video and try to guess what this infinite product might converge to. All right, so let's start pulling this thing apart. The first term, square root of 2 over 2, that is just cosine of pi over 4. Now here's the first surprise. Every single term in this product actually turns into a cosine with a smaller and smaller angle. It's kind of fascinating. What we're really doing here is pulling out a factor of 2 from each radical. That little move lets us rewrite each term in terms of the previous one. So, for example, the second term can be rewritten using the very first term, which we already recognize as cosine of pi over 4. And once you see that, the whole nested structure starts to make a lot more sense. Then we rewrite the inside. Apply that very beautiful trig identity. 1 plus cosine of 2 theta equals 2 cosine squared theta. And suddenly, boom, everything collapses neatly into cosine of pi over 8. And the next term does the same thing. It becomes cosine of pi over 16. And then cosine of pi over 32, and so on. So our product P becomes cosine of pi over 4 times cosine of pi over 8 times cosine of pi over 16 times cosine of pi over 32. Now here comes surprise number 2. And honestly, it's absolutely amazing. Instead of crunching this analytically, we can interpret this entire cosine product using geometry. Take a circle and inscribe a regular n-gon inside it. Then double the number of sides so it becomes a 2n-gon. Now, the way you find the area of an n-gon is by splitting it into n identical little triangles. I'm not going to walk through every algebra step here, but if you take the base and the height of one of those triangles, you can work out a formula for the area of the n-gon and another one for the 2n-gon, and then compare them. The only trig fact you really need along the way is that sine of 2 theta equals 2 times sine theta times cosine theta. And it turns out, and this part is honestly really beautiful, that the ratio of those two areas comes out to be cosine of pi over n. So cosine of pi over 4 is the area of the square divided by the area of the octagon. Cosine of pi over 8 is the octagon over the 16-gon. Cosine of pi over 16 is the 16-gon over the 32-gon, meaning our product is actually a giant chain of polygon area ratios. And surprise number 3 is the cleanest one. When you multiply all these ratios together, everything cancels. A 4 over A8 times A8 over A16 times A16 over A32, and so on, until the only thing left is a 4 divided by the area of the circle. As the number of sides goes to infinity, the polygon becomes the circle itself. So the infinite product becomes the area of an inscribed square divided by the area of the whole circle. For a unit circle, the inscribed square has area 2. The circle has area pi. So the entire infinite nested radical product equals 2 over pi. Isn't that just very beautiful? Something that looked chaotic at first turns into this elegant geometric ratio. Hope you guys enjoyed this absolutely amazing chain of surprises. If you solved it differently or if one of the surprises caught you off guard, let me know in the comments. And if you love these fascinating little math journeys, don't forget to like, comment, and subscribe. More beautiful problems are coming up. Thanks for watching, and see you next time.